Foodtubes is a proposed network of underground pipeline capsules to transport food and other goods. The system would consist of 2 meters long metal capsules shifting through underground tunnels at speeds of up to 60 miles per hour, directed by linear induction motors and routed by intelligent software to their destinations. The concept was initially developed by Noel Hodson and was engineered and developed for use in the United Kingdom. The Foodtubes Group estimates the system construction to cost only $5 million per kilometer and claim that implementation of it could save billions of liters of fuel per year, reduce street-level pollution and greenhouse gases, and free up congested roads. The group has developed a plan to link all the food outlets, schools and other major buildings in the London Borough of Croydon with an estimated construction cost of £400 million and an estimated profits of £80 million per year. Concept. The concept for Foodtubes was initially developed by Noel Hodson, a professional project planner and project manager. Hodson chose pipelines as his method because pipelines are believed to be the most efficient minimum weight vehicles. Because there is little to no vehicle weight, MWVs succeed in keeping the vehicle's curb weight at the least possible value, where curb weight is the weight of a vehicle with all necessary operating equipment and fuel. The vehicle is defined as the container used to transport freight. Using pipeline capsules, most of the weight in the capsules would come from the freight itself, whereas in current systems using trucks, most of the weight comes from the vehicle. The Foodtubes team. Noel Hodson has established a team of 20 engineers and scientists to take the concept into the development stage. As of March 2011, the core Foodtubes team includes Executive Team Noel Hodson, Foodtubes Coordinator, CEO, Dr. Jonathan Carter, Freight Logistics Consultant, Director of Container World, Dave Wetzel, Transport and Communities Consultant, Transport, Public Finance, Local Government and Sustainable Land Policy Consultant, Sarah Hadland, Partner, IPR Lawyer, Boyes Turner, Lawyers, Reading, UK. Consultants Drive, Juan Eduardo Barrera Cortez, CommerceNet Spain General Secretary, Professor Susan Collier, Collier Campbell Design, London, Alan Foster, Managing Director of Force Engineering, UK, Andrew Frayling, MD of SES Construction Software Limited, Brian Graves, Director of Engineering Technology Transfer Team, Imperial Innovations, Dr. Robert Judd, Senior Consultant at GL Industrial Services and Stoner Software, Professor Fred Taylor, Halley Professor of Physics at Oxford University, Distinguished Visiting Scientist at NASA's Jet Propulsion Laboratory at the California Institute of Technology, Ted D. Watson, Reinsurance Consultant, 20 years experience in group boards of reinsurance brokers, engineering. Foodtubes plans to transport food in lightweight 1 meter by 2 meter tubes via underground pipelines. The capsules and pipes would be computer-controlled, and propelled by either linear induction or air pressure. Linear induction runs on the principle of the Lorentz force, in which a force on the capsule is produced using a magnetic field and an induced current. If controlled by air pressure, Foodtubes would operate under the same concept as pneumatic tubes. The project plans to serve farms, producers, processors, packagers, wholesalers, retailers and recycling units. Foodtubes plans to use no-dig trenchless technology to install pipelines throughout the city, which encompasses a large array of techniques that involve installing underground pipes with little damage or intrusion to the surface. Current plans involve 100 kilometers of pipeline circuits and 400 terminals to and from retailers. Environmental impact. A large amount of air pollution in the world is caused by carbon dioxide emissions from cars. Many of these emissions come from large freight trucks carrying food and other cargo. If installed on a large scale in the UK, Foodtubes would reduce carbon dioxide levels added to the atmosphere by 8%. and save 17 billion litres of diesel per year. According to estimations by the company, in large cities such as Croydon, London, the project would save 90% of fuel and energy. Presently, 92% of energy for moving freight is used to move the vehicle, and only 8% used to transport the cargo itself. A more efficient system such as Foodtubes would save both energy and money by saving fuel and time spent transporting food in traffic. Recognition. In 2008, the Foodtubes project was a finalist in the St. Andrews Prize for the Environment, an international initiative by the University of St Andrews in Scotland and the independent exploration and production company ConocoPhillips. As one of two runner-ups in the competition, Foodtubes received $25,000 USD funding money. The Foodtubes team was also invited to give commercial transport applications to London, Buenos Aires, and the University of Texas. Two oil firms have also sought out the company, with an interest in installing a pipeline in Canada and the Middle East. Cost. Due to previously mentioned trenchless no-dig technology, Foodtubes pipelines are relatively economically friendly. The company estimates that construction of the Foodtubes system will cost approximately $5 million USD per kilometer of pipeline. The current production cost for a 4-lane highway is $28 million per kilometer. For the current plan in the city of Croydon, construction costs are estimated at £400 million with estimated profits of £80 million per year. Thus, a Foodtubes system in a city such as Croydon would pay for itself in approximately 5 years.